Hello, my name is Mr. Asprey and this is an EDEXCEL AS Further Maths Core Pure paper from 2022. Let's do it. Let's get into it. Come on. Love a bit of further maths. Right, we're starting with matrices. And it says show that there is no k for which blah 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 minus 3c plus ki equals 0. No problem. Right. Let us get started then by multiplying a and b. Let's do that. So I'm going to do, where am I going to do it? I'm going to do it right here. So AB is equal to, A is obviously 4 minus 1, 7, 2, minus 5, 8. And we're multiplying that by B, which is 2, 3, 2. Minus 1, 6, 5. And that is perfectly legit to do because when the first matrix is 3 by 2, because it has 3 rows and 2 columns, and the next one is 2, because it's got 2 rows by 3, because it's got 3 columns. And as long as the two numbers here are the same, the two numbers next to each other, then you're legit. You can multiply the matrices. And what it also tells you is what the output will be, because the output will be a 3 by 3 matrix. So it's the two on the outside tell us what the output is, and that's going to be a 3 by 3. So it's going to be a 3 by 3 matrix, so it's going to have 9 elements to it. So I'll split it up like this. And let's find the top left. Okay, top left is the top row multiplied by the left column. So 4 times 2 is 8, and then minus 1 times minus 1 is 1, so 8 plus 1 is 9. And then we've got 4 times 3 is 12, take away 6 is 6. 4 times 2 is 8, take away 5 is 3. Okay, middle row and left column, so middle row. So 2 times 7 is 14, and then minus 2 is going to be 12. 7 times 3 is 21. Plus 12 is 33, and 7 times 2 is 14, and plus 10 is 24. Okay, bottom row, so that's minus 5 times 2 is minus 10, and 8 times minus 1 is minus 8, so that makes minus 18. Minus 5 times 3 is minus 15, and 8 times 6 is 48. 48 take away 15 is 33, and minus 5 times 2 is minus 10, and 5 times 8 is 40, so that makes 30. Okay, fantastic. Right, next I need to take away 3c. So AB minus 3c. Okay, so let's just take away 3 lots of c, shall we? So let's look at the top left component, which is 9, and then I'm going to take away 3 lots of 5. So, oh no, take away 3 lots of minus 5. So I'm going to be adding on 3 lots of 5 to 19, which is going to give me 24. Okay, the next one is 6, and I am taking away 3 lots of 2, which is minus 6, so that's going to be 0. And then the next one is 3, and I'm taking away 3 lots of 1, so that's also going to be 0. And here I'm going to do 12, take away 3 lots of 4, which is 0. 33, take away 3 lots of 3 is 33 minus 9, which is 24. And then we next have 24 minus 3 lots of 8, so that's 0. And I'm going to have minus 18, take away 3 lots of minus 6, which is 0. And then 33, take away 3 lots of 11 is 0. And then finally 30, take away 3 lots of 2 is 24. Okay. That's brilliant. And if I was to rearrange this equation, I'd minus the ki to that side. It means that this should equal minus ki. Like that. Okay, perfect. And what is the identity matrix, or what is minus ki? Well, minus ki is minus k times by the identity. The identity is 1, 0, 0. 0, 1, 0, 0, 0, 1. If I times that through by minus k, well, these just turn into minus k's. And we said that's equal to this matrix here, which has the 24s going across the diagonal. So that means that minus k is equal to 24. So k is equal to minus 24. Okay, lovely. Let's move down. Next it says explain why there can be no constant m such that this equation holds. Well, this equation is different because it has b times by a rather than a times by b. And what happens if we try and do b times by a? Well, if I was to do b times by a, then I would be multiplying a 2 by 3 by a 3 by 2, which you could do because, again, the 2 in the middle are the same, but it tells us what the output will be, and the output will be a 2 by 2. So b times a would give a 2 by 2 matrix, and we cannot subtract 3c because C is a 3 by 3 matrix, as C is a 3 by 3 matrix. So we can't do a 2 by 2 minus a 3 by 3. It just doesn't make sense. Okay. Great. Next up, show how this matrix can be used to solve the simultaneous equation. Well, that's the matrix C, sorry. The matrix C happens to have the same coefficients as this simultaneous equation, as you can see here. So that means I can rewrite this simultaneous equation as the matrix C multiplied by x, y, z is equal to the numbers on the right hand side. So I can say C multiplied by x, y, z is equal to minus 14, 3 and 7. Okay, now I can apply the inverse function to both sides. And let's see what will happen if I were to do that. Let's just give myself a little bit of space here. There we go. So if I was to apply the inverse function, which is c to the minus 1 to both sides, then c to the minus 1 times c cancels out, and I'm just left with my x, y, z, which is my solution to the equation. And here I've got to do the inverse function of c multiplied by minus 14, 3 and 7. Okay, we need our calculators to do this. Okay, calculator. So what we need to do is go into matrix mode, which is over here, number 4. And then we need to define matrix A, which is going to be our matrix C, actually. But it's got 3 rows and it's got 3 columns. And then you just plug in the numbers as shown on the simultaneous equation, the coefficients. I've done that already, so that's great. And then what you need to do is press AC and go to Option, and I want to define a second matrix. So let's define matrix by pressing 1, and let's define matrix B, and that's going to be our numbers here on the side. So the minus 14, the 3 and the 7. So I need to have a 3 rows there, but 1 column. And then I type in the numbers minus 14, 3 and 7. Okay, and then you press AC again. And then what I'm going to do is press Option. And I want mat A first. But I want the inverse of that. So I press X to the minus 1, this button here. And then I want to multiply that by Option mat B, which was our minus 14, 3 and 7, and then press equals, and then there are the solutions. So I can just say this is equal to 3.5, 3 and minus 2.5. Okay, so to solve the equations, I can say that well, I'm done. Actually, that's it. I don't need to write it out any other way. That's perfect. That tells me X, Y, and Z. Job done. Question number 2, and we've got a bit of complex numbers here, and it wants it in the modulus and argument form. Okay, so the first thing I'm going to do is I'm just going to draw a little sketch of what's going on, perhaps on an argon diagram. So I'm just to see which quadrant this complex number is in. So it is on the real axis. We are going 4 root 3, so that's going to the right about here, and then we're going down 4. So it's about here. Let's say it's about there. Okay, and I'll just draw a line connecting it up, and I'll label this W like that. Right, so the modulus, the R, is the distance that it travels. So we use Pythagoras to work that out. So I'll take 4 root 3 and I will square it. And I will add that to minus 4 squared. Just like that. And rather than using a calculator, that's going to be 16 times 3, which is 48. And that's going to be 16. So that's root 64, which is 8. Perfect. Okay, next I need the angle. Well, we can use trigonometry to work out the angle here. We know that it's this much along and this much down. So that's 4 root 3 and that is 4. So working out the angle theta in here, then I would just do tan to the minus 1. So I do tan to the minus 1 of 4 over 4 root 3. I always keep it positive when working out the angle, and then what I'll do is I'll apply the negative because it's below the axis afterwards. Okay, so let's do tan to the minus 1 of 4 over 4 root 3, which is the same as 1 over root 3, which is 30 degrees. Or pi over 6. Now, because it is below the axis, then we measure that as a negative angle. Okay, so the correct answer is negative pi over 6. But anyway, it asked me for W in that particular form, so I need to write it out in that form. So W is 8 cos of minus pi over 6. Plus I sine of minus pi over 6. Bosh. Done. Okay. Whoops, get that calculator back. I'm going to need you in a minute. Okay. Show on a single diagram the point representing W. Oh, already done that. Fantastic. The locus of points defined by the argument of Z plus 10I is equal to pi over 3. Okay, right, whenever we see this word locus, then it means I need to find the difference between any given complex number, Z, and Z1, which is a given complex number in here. Okay, so how am I going to do that? Well, I need to rearrange this then to write it as the argument of Z minus something, because I'm always looking at the difference. So what do I need to put in here to make plus if I've already got a minus? Well, it needs to be a minus 10i. So that's the complex number zi, which I'm going to base my argument around. Okay, z1, sorry. And it's minus 10i. Okay, so let's go down to our diagram here. I'm going to have to extend this out a bit further. Because if that's minus 4, then I'm going to go down to minus 10, which is going to be about here. Okay, like that. Okay, and next what I would do, whenever I'm doing the argument, I need to draw a line going off to the right, like this. This is like my 0 line. That's 0 degrees from the point minus 10i. And then I need to measure 60 degrees, because pi over 3 is 60 degrees, from that line. So it's going to look something like this. Okay, and it's just going to carry on and on. So that's probably about 60 degrees. So that looks about right to me. Yeah. Okay, that in here, this would be 60 degrees. And that does a good job. Yes, it does. I'm happy with that. Okay. Next, it says determine the minimum distance of W from the locus that we've just drawn. Okay, so we need to find the smallest value, the distance from W to the blue line. So it could be that, but it's not going to be that, is it? In fact, it could be this, but of course it's not going to be that. I'm pretty sure it's going to be just directly there. It's going to have to be perpendicular to that blue line. So let's have a look at our angles. This might help us out somewhat. If I rewrite this as, I think sometimes it's easier to understand it when we use just degrees. So this was 30 degrees, which means that this over here is 60 degrees. This is 60 degrees, which means this is 30 degrees, which means this is a right angle because you've got 60, 30 makes 90, so that must be a right angle triangle. So now we know that is perpendicular, that the green line and the blue line are perpendicular. Then we can work out, and we know the whole of the green line is 8. So what we need to do to work out this dark green bit, which is going to be the distance we're looking for, is to work out this orange bit here. Now that orange bit is part of a right angle triangle, of which we know that this side length is 10. So the orange bit is the opposite. It's opposite this 30 degree angle here. So I can say that sine of 30 is equal to the opposite O over the hypotenuse, which is 10. So the bit which I'm looking for is 10 sine 30. And of course sine of 30 is a half. So therefore I'm looking at 5. So that opposite here, let's call that the orange O, is 5. So the dark green bit, which is the perpendicular distance from W to the argument line, which is the shortest distance from W to the argument line, is equal to 8 minus 5. So min distance is equal to 8 minus 5, which is 3, and that is a wrap. Sweet. Okay, next question. We've got a rotation, which they've given us. Very nice of them. And we've got a point P, and we want Q, which is the image under the transformation reflection in the plane y equals 0. Okay, so let's think about this in 2D. What happens when you reflect in the line y equals 0, which is also the x-axis? Well, let's say I've got a point up here. Let's call this point, I don't know, 1, 3. When I reflect it in that line y equals 0, then you can see that this is going to be 1 minus 3. So the y coordinate switches sign. And that's the same for 3D. So if I'm reflecting in y equals 0, the y coordinate changes. So Q is going to be 8 minus 3, 2. Perfect. Okay, next it says that the point R is under the image of P under the transformation rotation 180 degrees. So that's the same anti-clockwise about the y-axis. We've already got this. So this is just meaning that in this case theta is 120, and we can use this this matrix here. With respect to the right hand rule, yeah, blah blah blah. Determine the exact coordinates of R. Okay. So what we're going to need to do is we're going to need to do cos of 120, 0, sine of 120, 0, 1, 0, minus sine of 120, 0, cos of 120. and we're going to need to multiply that by the position, or sorry, the coordinate which we want to transform, and that is the coordinate P, which is 8, 3, 2. Okay. So let's do that. We'll start with cos of 120. I'm in the wrong. Sorry about this. I need to be in degree mode now. So that's minus a half times by 8 is going to give you minus 4. 0 times by 3, that cancels out, and then sine 120 times by 2. So sine 120 is this, times it by 2 is going to be root 3. So I'm going to add those up, and that's going to give me minus 4 plus root 3. That's the top row. Okay, now the middle row, so I do 0 times 8 is 0, 1 times 3 is 3, and 0 times 2 is 0, so it's just 3 there. Okay, so we've got minus sine of 120, it's going to be minus root 3 over 2, and I'm timesing that by 8, which is going to give me minus 4 root 3. And then I've got 0 times by 3, 0. Cos 120 was minus a half, and we're timesing that by 2, so that gives you minus 1, so minus 1. Okay, perfect. Next part of the question. Oh, actually, it does say the exact coordinates of R, so I'm going to be very careful here. I'm not going to write it as a position vector. I'm going to write it as coordinates. So that's the x coordinate, that's the y coordinate, and that is the z coordinate. Perfect. Okay, next we need to find P to R, the distance P to R. So the distance between P and R, well, how do we find the vector P to R? Well, it's OR minus OP. So that means that we need to do minus 4 plus root 3, 3 minus 4 root 3 minus 1, minus P, which is 8, 3, 2. And then we'll take the modulus of that. So this is going to be minus 4 minus 8 is minus 12. Yeah, minus 12 plus root 3. And then that's going to be 0. And this is going to be minus 4 root 3. Minus 1 minus 2 is minus 3. Okay, so how do we work out the magnitude of that? Well, we go to our calculator and we do the square root of, in brackets, minus 12 plus root 3. That needs to be squared, plus 0 squared, don't need to bother writing that down, and then minus 4 root 3 minus 3, close bracket, also squared, equals, and I get 2 lots of root 51. Okay, great. Next it says show that those two vectors are perpendicular. Okay, well I know what PR is. I know what that is. And if I dot that with PQ, then I should get 0 if they're perpendicular, because the dot product of two perpendicular vectors is 0. So I need to dot PR, which is this one, with PQ. Now what's P to Q? Okay, so let's look at P and Q. So P is 832 and Q is this 8 minus 32. So when I do P to Q, I'm obviously doing Q minus P, which is going to give me 0 for the X. The gap between the Y's is going to be 6, and the Z's are both 2, so when I subtract one from the other I'm going to get 0 as well. So P to Q is 0, 6, 0. Okay, so 0, 6, 0. I'm going to do the dot product. So the top line times these two together, it's going to give me 0. The middle line is going to give me 0. And the bottom line is also going to give me 0. So that equals 0. Therefore, they are perpendicular. If the dot product equals 0, then the two vectors are perpendicular. And now it's asking me to find the exact area, PQR. Okay, let me just get some more space. I'll work where the calculator is. Okay, so let's look at this then. So PQR. Well, if I was to draw the triangle, it would look something like this, where P is down here, because P to R and P to Q is perpendicular, so there's a right angle there. I know that P to Q, it has a modulus of 6, because, well, the components are 0, 6 and 0, so when I square them all and then square root, I'm going to get 6. And P to R, we know what the modulus of P to R is. We've already worked that out. It's 2 root 51. So we should be good to go. The area is just a half of the base times by the height, which is going to give me 6 root 51. Perfect. Bosh. Okay, question number 4, and we've got the roots of polynomials. Now I've put the summary of key points on the right hand side here, as these are some things which really you should commit to memory. Okay, so first off we're looking at the sum of the squares, which is down here, rule number 6, and this is a quartic. So what we could do, if you didn't know them, is you could just take the roots like this and square and then expand out, and what you will get is you'll be able to rearrange such that the sums of the individual squares like such are equal to this minus 2 lots of all of the pairs, the sum of the pairs. Okay, like you can see down here, the sum of the pairs. Okay, and this is essentially just the sum of all of the individual roots, like that. Now, what we should know is that the sum of the individuals is equal to minus b over a. The sum of the pairs is equal to c over a. The sum of the triples is equal to minus d over a. And finally, the sum of the all of them multiplied together essentially is equal to e over a. Okay, and just so we don't make any mistakes, this is a, this is b. There is no c because there's no x squared term, so this is d and this is e. Right, we should be good to go now. So the sum of the roots is going to be minus b over a, which is minus 5 over 3. That needs to be squared. Minus 2 lots of the sum of the pairs, which is c over a. There is no c, so that's 0. So my answer is just minus 5 over 3 squared, which is 25 over 9. Okay, good stuff. Job done. Second part. The reciprocals. Okay, so if you look down here, it says the rules for reciprocals. For the quartics, you've got this right here. Again, if you're struggling to do this, you can't remember what it is in the exam, you could just make this over one denominator. So make it over alpha, beta, gamma, delta. And then you should get 2 lots of, on the top, the sum of the triples. Like so. Okay, so for us, in order to solve this, we just need to do 2 times by the sum of the triples, which is minus d over a. So that's minus 7 over 3. So that's 7 over 3. And that's all over all four of them times together, which is the sum of the four roots times together, which is E over A, which is 6 over 3. 6 over 3. Okay, so a bit of simplifying. This is going to be 14 over 3, 6 over 3. Both top and bottom are over 3, so that can cancel. So it's 14 over 6, which is 7 over 3. Lovely, lovely. Okay, this is nasty because we are going to have to expand this out really. Okay, so in doing so, I think probably the quickest way of doing it is just expanding out these two first. And that's going to give you 9 minus 3 alpha minus 3 beta plus alpha beta. And then if I was to expand out the other side, I'm going to get something very similar. I'm going to get 9 3 gamma minus 3 delta plus gamma delta. Okay, and now we're going to need to multiply all of this out. So I'm going to start by multiplying the right bracket by 9. And this is going to give me 81 minus 27 gamma minus 27 delta, and then plus 9 gamma delta. Okay, now let's times it by minus 3 alpha. So that's going to give me minus 27 alpha plus 9 alpha gamma plus 9 alpha delta, and then minus 3 alpha gamma delta. Great, halfway there. Now let's times through by minus 3 beta. I'm going to do it here just simply because it's just easier to keep track, because this is going to be very similar. I'm just changing the betas, or the alphas, to betas. So it should look like that. Okay, and then the last one is timesing alpha beta by everything over there, and I'll do this just up here. So that's going to be 9 alpha beta. It's going to give me minus 3 alpha beta gamma minus 3 alpha beta delta, and plus finally alpha beta gamma delta. Okay, great. So what have we got? We've got 81. That looks like the only constant. And then what about the singles? We've got minus 27 of each of the singles. So this is the same as minus 27, the sum of the singles. Okay, let's look at the doubles. What have we got? We have 9, got 9, got 9, got 9. There should be 6 doubles in total if we've done it correctly. And there are, perfect. So that is 9 lots of the doubles. And then let's look for the trebles. And we've got minus 3. There should be 4 of these, which there are. Lovely. So minus 3 lots of the trebles. And then finally the, well, just all them times together, there's only one of those. So there's only, and there's the coefficient is 1. Perfect. Okay, so 81 minus 27. We knew that the sum of the singles was minus 5 over 3. The sum of the doubles, I think we've worked that one out already. It was 0. The sum of the triples, we've worked that one out as well. It was 7 over 3. And the sum of all 4 was 6 over 3. Okay, great. So all we need to do is add this all up, and to save you the bother, the answer is 121. Bosh. Job done. Okay, here we go. Next question, question number 5, and I've put these summation formulas which you get given in your formula booklet on the right. It says use the standard summation formulae to show that blah de blah de blah for all n natural yada yada yada. Okay, so what we're going to do is we're going to split it up into 3 parts. So first off, the sum of n r equals 1. There are 3 of them, and that's going to be of r squared. Minus 17 of the sum of the r's. And then minus 25 lots of just the sum of 1. Like this. Okay, great. Right, so now I can scroll down a little bit. Oops, let me take you down with me. Okay, nice. So we're going to have 3 lots of r squared, which we're told over here is 1 over 6, n plus 1, 2n plus 1. And then we're going to take away 17 lots of r, which we have to know, but that one is a half n plus 1. And minus 25 lots of 1, which is just n. Okay, and what particular form did they want it in? Just an n on the outside, factorized out. Okay, got it. Right, so 3 lots of a 6 is a half n, and then we have n plus 1, 2n plus 1, and over here we have 17 lots of a half n plus 1 minus 25n. Okay, so we can take an n out, like so, and then we can multiply out, let me multiply out this first, and then I will times it by half. So we're going to get 2n squared, times by half is n squared. We're going to get a 2n and a 1n, which is going to make 3n, so times by half is 3 over 2n. And we're going to get a 1 times a 1 is a 1, and then times by a half. Okay, here we're taking out the n, and we're going to multiply the 17 over 2 by n. So we get minus 17 over 2n. And then I'm also multiplying, or just taking away, sorry, 17 over 2, when I times it by the 1. Okay, I've taken the n out here, so I'm just left with minus 25. Okay, so n squareds, I've got 1 of them. N's, I've got 3 over 2 minus 17 over 2, which is going to give me minus 14 over 2, which is just minus 7. And in terms of the numbers, I've got a half minus 17 over 2, so that's minus 16 over 2, which is minus 8. And minus 25 as well gives you minus 33. And we're done. Lovely. Okay. Right, next question, and it says explain why this summation is equal to minus k root 3. Okay, so let me write that summation down a bit lower, and then we can figure out why that is equal to this. So it is the summation 3k r equals 1 r tan of 60r. Okay, so if in doubt, what we can do is we can start writing them out. So the first term, when r is 1, we're going to get 1 times tan of 60. So it's just going to be tan of 60. The next one, r is 2, we're going to get 2 lots of tan of 120. Times in the 60 by 2. And then we're going to get 3 lots of tan of 180. And then after that, we're going to get 4 lots of tan of 240, 5 lots of tan of 300, and then 6 lots of tan of 360. Okay, so that's useful. let's quickly look. So we know that tan of 180 is equal to 0. So and also tan repeats every 360, so tan of 360 is also equal to 0. So these ones are going to be cancelled out. The first term, tan of 60, is equal to root 3. So we're going to get root 3. And then tan of 120, we can see is minus root 3. So we're going to get minus 2 root 3. Okay, and then this one was 0. And then for tan of 240, so tan of 240, because tan repeats every 180, it's going to also be root 3. So this is going to be 4 root 3. And again, because it repeats every 180, it's going to be the same, these two. So this is going to be plus minus 5 root 3, like this. Okay, so what does this mean? This means every 3 terms we achieve, well, what do we achieve? Well, we've got a root 3 minus a 2 root 3 and a 0, so that's minus root 3. And over here we've got 4 root 3 plus minus 5 root 3 plus 0, which is also minus root 3. So every 3 terms we achieve minus root 3. Okay. And let's look at the summation. So the summation is up to 3k. 3k, which means that if we split it up into groups of 3, there are going to be there's going to be k lots of groups. Okay, so we could then say that as the summation is up to 3k, there will be k groups of 3, each with a sum of minus root 3. So the overall sum will equal k multiplied by minus root 3, which is what we were trying to prove, I believe. Yes, perfect. Okay, now we need to do, for 6 marks, the n that satisfies this first one, which we've already kind of worked out, but starting at 5. And then this second one, which we've just looked at, times by 15, but starting at 6, and it has to be squared. Okay, let's start with this one here. We know already that it simplifies to n squared minus 7n minus 33, but it starts at 5, which means we need to take off the first 4 terms. Okay. So what we have is we have n squared minus 7n, sorry, n outside, n squared minus 7n minus 33. I need to take away the first 4 terms. So that happens when n is equal to 4. So I need to take away 4 lots of 4 squared minus 7 times 4 minus 33. Okay, so let's figure out what that value is. So the first 4 terms is going to give me a value of this. And I need to take this away from my summation because it starts after the 5th term. Okay, so that's minus 180. I'm taking that away, so I'm adding on 180. So this is going to be n cubed minus 7n squared minus 33n plus 180. Okay, great. So that's the left-hand side. And we're told that's equal to 15 times this summation starting at 6. Okay, so that means I need to get rid of the first 5 terms of that summation, which we've already looked at. The first 5 terms were 1, 2, 3, 4, 5. And these will sum up to minus 2 root 3. Yes, because each group sums to minus root 3, so there are 2 groups there, excluding the 0, but that doesn't count. So that's going to take us to minus 2 root 3. So that needs to come off of this. Okay, so it's 15 lots of... it's 15 lots of the summation, which we know what the summation is because we worked it out. It sums to it sums to k times minus root 3. Okay, and in this case we're going to 3n. So rather than k we're using n. So therefore this will sum to minus n root 3. But then as well we've got to take away that minus 2 root 3. So this is minus n root 3, take away minus 2 root 3 because it starts after the 6th term. It means I've got to take away the first 5 terms. And then this needs to be squared. Okay, right, I think we're on to something now. Okay, so in squaring this, I'm going to get this term. In fact, let's not rush this. Let's make this nice and clear. So this is the same as what do we have? We have minus n root 3 plus 2 root 3, which is the same as root 3 2 minus n, like that, which then needs to be all squared. So squaring the root 3 is going to give me 3 lots of, and when I square this I get 4 minus 2n plus n squared. So this is going to be 4 minus 4n plus n squared. Okay. And this can be expanded out. I've got 15 times 3 times 4. 15 times 3 times 4 is 180. I've got another 15 times 3 times 4 n, so that's minus 180 n. And I've got 3 times 15 times n squared, so that's plus 45 n squared. Okay, we can cancel the 180s from both sides. I can minus the 45n from both sides, which gives me minus 52n squared. And I can add on the 180, which gives me plus 147n is equal to 0. Okay, I can factorize out an n. And then I need to solve this quadratic. So I'm going to do that on my calculator. Equation, polynomial degree 2, and we've got 1, we've got minus 52, and we've got 147. Great, we've got a whole number, that makes me feel great. We've got 3, so this obviously n equals 0, which is not going to be a solution. N equals 3 and n equals 49. So I suspect here that n equals 49 is the correct answer. We can't have n equals 3. And why is that? Well, these summations start from 5 and from 6. So we can't have just n is equal to 3 because that wouldn't make sense because these ones start at 5 and 6. Woof, what a question. Okay, it's a bit of a wedge question, so I've zoomed out a little bit. We've got a tennis court. It's been modelled by a horizontal plane, blah, 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 blah. The origin on the ground at the centre of the court. And these are the unit vectors, yes, and k is the unit vector upwards. After being hit, a tennis ball modelled as a particle moves along the path with this equation, okay, where lambda is a scalar parameter. Assuming that the tennis ball continues on this path until it hits the ground, find the value of lambda at which the point the ball hits the ground. Okay, so if that is the case, then the ball must hit the ground, well, when the k component is 0. So we need the k component to equal 0. And the k component is 0.84 plus 0.8 lambda minus lambda squared equals 0. Okay, so we would go to our calculator here and we would type in this quadratic, which is -1, and it's 0.8 and it's 0.84, and we get that lambda is equal to 7/5, seeing as lambda has to be greater than 0. Perfect. Okay, the direction in which the ball is moving at a general point on its path is given by this. Okay, write down the direction in which the tennis ball is moving as it hits the ground. Right, well, this is just simple substitution. We just need to substitute in that lambda value of 7/5. So it's 9 minus 4.6 times 7/5. Okay, so the I component is 64/25. And the J component is 15, because that's not dependent on lambda. And the next one is 0.8 minus 2 times 7/5. That's minus 2. So oh, why my scribble's not working? Okay, so that's minus 2k. Great. Part C, hence find the acute angle at which the tennis ball hits the ground, giving your answer in degrees. Okay, so this is the direction that it's moving in, and we need to find the angle that it makes with the ground, and the ground is a plane. Okay, it's a two-dimensional object in space, and we define a plane by its normal vector, which is the one which can be perpendicular to the plane. So the normal vector of the plane is going to be 0, 0, 1. Just has one unit going upwards, or any amount of units, doesn't really matter, but that's just the simplest form. And when we do the direction between a line and a plane, because they're different, we have to use the formula which involves sine to get the acute angle. So the formula is this is equal to sine of the acute angle. Okay, so I'm going to dot the two vectors that I have here. And when I dot them, I get 0 times 64/25, 0. I get 0 times that, 0. I get 1 times minus 2, so I get minus 2. So minus 2 goes in there. Oh, sorry, if you're trying to find the acute angle, you need to modulus the this value as well. And then we need the modulus of A. Okay, so I'll need to do that one on my calculator. So it's the square root of 64/25 all squared plus 15 squared plus 2 squared, and that's 15.3. Okay, that's useful. And then what we need to do is multiply that by the modulus of b, which is just 1. So that should equal sine of theta. Lovely. That should be a 4. Okay, so let's just do let's do 2 divided by the answer, and then let's find the inverse sine of that value, and we get 7.5. Perfect. Okay, next question, and it says that the net is in this plane. R dot j is equal to 0, and we want to work out the position of the tennis ball at the point when it is in the same plane as the net. Okay, so let's substitute in the position vector r into the plane which we've just found, and that will tell us what lambda value the ball has when it is in contact with the net. So minus 4.1 plus 9 lambda minus 2.3 lambda squared minus 10.25 plus 15 lambda and 0.84 plus 0.8 lambda minus lambda squared needs to be dotted with 0, 1, 0, and that equals 0. So it's just this line here, minus 10.25 plus 15 lambda times by 1 is going to equal 0. So this tells me that 15 lambda is going to equal 10.25. So I need to do 10.25 divided by 15, and that gives me 41 over 60. So that's my lambda value, and now I need to sub that back into the position formula in order to give me my my position. Let's speed this up a little bit. Okay, so subbing into the x is going to give me 0.976 I, and then we'll sub into the next one, which is going to give me 0, obviously, seeing as we've just proved that it will do. And then subbing into the final one, I will need to do this following calculation, and let's just call that 0.9120. And that is the K. Okay, next one. It says the maximum height above the court of the top. The maximum height above the court of the top of the net is 0.9 meters. Modelling the top of the net as a horizontal straight line, state whether the tennis ball will pass over the net according to the model, giving a reason. Well, yes, it will, as the K value, which is this one, is greater than 0.9. Okay, so with reference to the model, decide whether the tennis ball will actually pass over the net. Well, I would say it's unlikely, as the diameter of the ball is greater than 0.920 minus 0.9, which equals 0.02 meters. So basically the gap between the ball, which is modelled as a particle, and the net is only 0.02. So if you actually consider it being a ball, then it's going to clip the net. So it will clip the net in the very least. Momentum may take it over. I think it covered all bases there. Yeah, happy with that answer. Good. Okay, proof by induction. Let's get into it. So first step is, as always, to do your base case, and that is when n equals 1. We need to show that it works for both sides. So on the left hand side we have minus 5, 9, minus 4, 7 to the power of 1, which is of course just minus 5, 9, minus 4, 7. Okay, we then look at the right hand side, and this is going to be 1 minus 6 times 1, 9 times 1, minus 4 times 1, and 1 plus 6 times 1, which is equal to minus 5, 9, minus 4, 7. And we can say that the statement is true for n equals 1. Perfect. The next step is the assumption stage, where we assume true for n equals k. And therefore we just write out the same statement, but we replace the n's with k's. So to the power k, and this is 1 minus 6k, this is 9k, this is minus 4k, and this is 1 plus 6k. Okay, great. And then the next step is to let n equal k plus 1, like so. And then we look at the left hand side. So the left hand side becomes minus 5, 9, minus 4, 7 to the power of k plus 1. Okay, so what does this mean? Well, this means that I need to raise this matrix, or times this matrix by itself, k plus 1 times. So what I can do is I can raise it to the power of k, but then I need to multiply it one more time in order to make it k plus 1 the power. So I can write here multiplied by one more time, like so. Now we've already assumed that this is true, so therefore we can replace this matrix to the power k with this matrix which we've assumed true. So 1 minus 6k, 9k, minus 4k, and 1 plus 6k. And then that will be needs multiplied by minus 5, 9, minus 4, 7. And what this should give us is this matrix, but with the k's replaced with k plus 1's. So sometimes what I like to do is just on the rough bit of working, just sub in k plus 1, because this is what we're going to be aiming for. So we're going to be aiming to achieve this in order to prove it true for k plus 1. Okay. So we need to multiply this. So it's going to give us a 2 by 2. We're going to get minus 5 multiplied by the first element, which is 1 minus 6k. So that becomes minus 5 plus 30k. And we're also going to have to do 9k times by minus 4, so that's minus 36k. Okay, that's the first element. Now let's do the top right, which will be the top row multiplied by the right column. So that will give me 9 minus 54k, and it will give me plus 7 times 9k, which is 63k. Okay, bottom left is going to be plus 20k, and also we're going to do 1 plus 6k times minus 4, which is minus 4 minus 24k. Okay, now bottom right is minus 4 times by 9, which is minus 36k, and then 1 times 7, and 6k times 7 is 42k. Okay, brilliant. Let's simplify this now. So that's minus 5 minus 6k. And this one is 9 plus 7k. No, it's not. It's 9 plus 9k. And this one here is minus 4k and minus 4. And this one here is 6k plus 7. Okay, so I need to write this now in terms of k plus 1. So I'm going to look over here and I'm going to notice, I'm going to check to see if this works out. And maybe what I'll do is I'll expand these just to see if they match up with these. And if they do, I can say that it's equal to that. So that's going to be 1 minus 6k minus 6, which is the same as minus 5 minus 6k, so that one's good. This one is 9k plus 9, which is good, that's correct as well. This minus 4k minus 4, yes, that's good. And the last one is going to be 1 plus 6k plus 6, so that's 6k plus 7, which is good. Perfect. So now what I can do is I can just write it as it is over there, and this shows perfectly that it is true for k plus 1. Perfect. Okay, so what's next is the following statement, and we can say that hence it is true for n equals k plus 1. And then since true for n equals 1 and if true for n equals k, then also true for n equals k plus 1. Thus it is true for all natural numbers n. Perfect. Okay, final question. And we've got this vase which has been created by wrapping this curve here around the x-axis 360 degrees. Okay, so with that being said, when that happens, we're going to create a diameter of 8 centimeters at the base. So therefore the A value must be 4. So that when we kind of rotate it around, it's going to become 2 times as bigger to make the 8. Okay. And now what we have is we have these two models, which when I scroll down I'll show you. Okay, so two models, and for each one we have to find the distance from the base at which the widest part of the vase occurs. Okay, so if we look at the first model, it's a sine graph that's been transformed upwards. And the sine graph will have a maximum halfway along. So this value here will be the maximum, where x is minus 4, because we know this is minus 8. And over here, again, the minimum will be here at 4. So the distance from the base to the maximum point is going to be 4. So 4 centimeters. And we can sub that into model A to find the height. Or actually, we'd have to sub in minus 4 to get the maximum right here. Okay, so subbing in minus 4 is going to give me y is equal to A, which we said was 4, minus 2 times sine of minus 90. When I sub in minus 4 times 45 over 2. So this is going to give me 6. So this distance here is 6. So that means that when that's wrapped around the x-axis, that's going to create a diameter of 12 centimeters. Okay, the second part is a bit trickier. We're going to have to expand out this and then differentiate it in order to find its maximum. So the top line will become x cubed minus 64x, and that's over 100. And then when I differentiate this, the a value is 4, by the way, but it doesn't matter. We differentiate it, it will go to 0. This will give me 3x squared over 100 minus 64 over 100. We want this to equal to 0 so we can find the maximum. Okay, I can times through by 100 to get rid of that, and therefore I can say that 3x squared is equal to 64. So x is equal to 64 over 3 square rooted, but we will get a plus or minus there. Okay, and the one I'm interested in is the negative one, because that's going to give me the maximum point, because it's on the left-hand side. So I'm looking at minus the square root of 64 over 3, and that gives me this value here, minus 4.6188. Okay. So that is, that means that it's going to be roughly somewhere like here. But the question asked me distance from the base. So I'm actually looking for this distance here. So that will be 8 minus that value. So if I take that previous answer and add 8 to it, that's going to give me the distance from the base, so 3.38. So the answer here is, for model B, 3.38. And how wide it will be, well, I need to sub my value that we just had into the original equation to work out how high up that maximum point is, and thus the value of it. So what I'm going to do is I'm going to do 4 plus answer minus 8, close brackets, answer plus 8, close brackets, all over 100. And it's going to give me 5.97. And that's the value of how tall it is at the top, which then gets rotated around, so it's going to give a diameter of twice that. So times that by 2 is going to give me the diameter of 11.94. Okay, great. So that's part B done. Okay, so now it says, using this information and making your reasoning clear, suggest which model is more appropriate, given that the diameter is 12 and it's just over 3 centimeters from the base. Well, you can see that both have a diameter pretty close to 12, so that's not really comparable. But this one has a much better approximation for the distance from the base. So with that being said, we will go with model B as 3.38 is a better fit. And the fact that their diameters are pretty much the same. Okay, now we need to use algebraic integration to find the volume of the vase using model B. So what that means is we're going to take this as our Y formula, and we're going to do the volumes of revolution formula around the x-axis, and I'm going to do that down here. Need a lot of space for this. Okay, so the formula is that we integrate between the two limits, which were 8 and minus 8, y squared dx multiplied through by pi, which we can leave outside, or the integral. Okay, so what was our formula? Well, it was a, which was 4, plus x minus 8, x plus 8, all over 100, which needs to be squared. Okay, and what I'm going to do is I'm going to multiply this by this bracket here, this square bracket, by 100 squared, which is going to cancel the hundreds. So it's going to multiply through by 100, and it's going to leave me with this. And in doing so, that's just cleared that fraction, but I'm going to have to divide outside the bracket by 100 squared, which is 10,000. Okay, that's good, so that's going to be more helpful. And now I need to expand this. So let's just do this over here, just to save some space. So 400 plus, this was x cubed minus 64x, needs to be squared, so times by itself. Okay, so 400 times 400 is 16 with 4 zeros on the end. And then we're going to have 400 x cubed, and we're going to get 400 times 64, which is plus, should I say minus 25600x. Okay, now timesing by the x cubed here. So I'm going to get a 400 x cubed. I'm going to get an x to the 6, and I'm going to get a minus 64x to the 4. And then finally, timesing through by the minus 64x, I'm going to get another minus 25600x. I'm going to get a minus 64x to the 4, and I'm going to get a plus 64 squared x squared. So 4960x squared. Okay, great. So let's then collect all the terms together. So that's the constant term. How many x's have I got? I've got two lots of 25600. 25600 times by 2. And those are both negative, so it's minus 51200x. And what have I got for x squareds? I've got a plus 4096 x squared. X cubes, I've got 800 x cubed. And then the final term, I believe, oh no, there's some x to the 4s here, of which there are two negative 64s, which makes negative 128 x to the 4. And finally, I've got x to the power 6. Okay, dx. Okay, so now I just need to integrate this. So I can still keep this outside. And I need to up the power and then divide by the new power. So I'm going to be dividing this by so this is just I'm going to add the x on here, and then I'm going to up this power and divide it by the new power, which will be 2. So dividing it by 2 will give me this. I need to divide this by 3, which I don't think it does divide by 3, so I'll just write it as a fraction. Divide this by 4, that goes nicely. Divide this by 5, that doesn't work, so I'll just write it like this. And then I will do this over 7. Okay, and that is between 8 and -8. Lovely. Okay, so this is going to be done on the calculator. Okay, I've just put it all into the calculator, and for 8 we get 620,583.0095, and then I'll do the same for -8. Okay, just done the same by subbing in -8, and I get -225,8983.01. Okay, so I'll need to then add that to the 620,583.0095, and then I'll need to divide that by 10,000, and then I'll need to times that by pi, and that will give me my final answer of 904.6. And it just says find the volume, so we're happy with that. It'll be centimeters cubed, and that sounds good to me. Okay, next part says the student pours water from a full 1 litre jug into the vase and finds that there is 100 millilitres left in the jug when the vase is full. Comment on the suitability of model B in light of this information. Well, this shows that 900 millilitres of water was used, which equals 900 centimeters cubed of volume, and 904.6 is approximately 900, so therefore the model is good. And just to double check that, you could always work out the percentage error, which in this case is, oh yes, minimal. Okay, 0.5% error. So that's a very good model. Hope you enjoyed that. Bye for now.